Hi friends, in the earlier video I talked about the piston and connecting rod. We have completed the cylinder block, crankshaft, piston connecting rod. Now in the sequence in this video I am going to explain about the cylinder head in detail. Cylinder head and about all the components fitted in the cylinder head like valves, guides, valve suites, springs, etc. What is the job of each and every component and how they will work, what is the material used in these components. Let us look into the cylinder head assembly. I am talking about the cylinder head assembly. This is the cylinder head assembly. This is the engine block and head assembly is mounted on the top of the cylinder block. Cylinder head also is one of the critical component in the engine. It's a very critical component which holds the complete valve mechanism and injectors in it. A typical 4-cylinder engine cylinder head looks like this. You can see there are total 8 valves, 4 inlet valves and 4 exhaust valves, and the valves are secured. This is the center one is the valve. It's exposed. The valve stem is exposed here, and this split one, the split pieces are called valve locks or valve collets. This is valve spring retainer. This is valve spring which holds the valve always closed position, and inside there is a valve guide, and the other side of the valve it is called valve head. We will be discussing in detail about each and every component. And these holes are provided for the push rods which are part of the valve operating mechanism. This is the same head. You can see the other direction. I told these are the areas for the valve seats. In this groove valve seats are inserted, so which are closed with the valve head. This is another 4-cylinder engine cylinder head which has 4 valves per cylinder, 2 inlet valve and 2 exhaust valve. This is 1 exhaust valve and 1 inlet valve, that is 2 valves per cylinder, and this is 4 valves. All the modern engines, majority of the modern engines are coming with this design. Why 4 valves means? To get more intake air inside the cylinder and to produce more power and to evacuate the exhaust gases outside. So the main purpose is to produce the more power in the confined cylinder area. This is another type of cylinder head. This is called an individual cylinder head. Large capacity engines do have this type of cylinder heads. Why? Because in case of any problem in the cylinder head, maybe crack, maybe damage, if the cylinder head is rejected, so the entire cylinder head has to throw away, which is going to be an expensive affair for the higher horsepower engines. So individual cylinder heads are made for that. Suppose one area in one cylinder some problem is there, it is enough to replace only that particular cylinder head. The back side of this individual cylinder head looks like this. This is again the 4-cylinder head. You can see this copper portion areas. These are called injector sleeves. These are called injector sleeves. These are provided to fit the injectors securely inside it and also to provide the sealing for the fuel passages. How the sealing takes place, that we will discuss separately in the injectors. And some of the injector sleeves are also directly exposed outside, directly exposed to the coolant in order to dissipate the heat at faster rate. And these hollow tubes which you can see here, these are called valve guides. So these are useful to guide the valves up and down movement. These are called valve guides. These are also replaceable after certain time. Now let us see what is the job of the cylinder head. Cylinder head has to give the sealing for the compression chamber. The top portion of the cylinder, top portion of the combustion chamber is sealed with this head. This is the place which seals the cylinder from top portion. Bottom portion is sealed by the piston and piston rings. During the combustion process, all that amount heat and all that thermal and mechanical pressure do act on the cylinder head also. All that act on the cylinder head also. So the material used for manufacturing the cylinder head should be able to withstand for such thermal and mechanical loads and stresses. Further, the thermal loads on the cylinder head are always cyclic. Cyclic in the sense during the power stroke, tremendous heat is generated, and during the interrupt stroke, because of the entry of the fresh air, sudden cooling happens inside the chamber. Sudden cooling and sudden temperature, these are called cyclic temperatures. So the material should be able to withstand for such cyclic temperatures, thermal loads and mechanical loads. And the other job of the cylinder head is to hold the complete valve mechanism securely and hold the injectors, and also to give the passages for the exhaust gases and inlet fresh air, and to give the passages for the coolant, lubricating oil, and even diesel in some of the diesel engines. And as this is providing the passages for the coolant, lube oil, to accommodate all these passages and to withstand for all the thermal and mechanical load. So the material used in manufacturing the cylinder head should be able to withstand for all the thermal and mechanical stresses and loads, and also should be able to flow freely during the casting process, because as I told, it has many internal passages. So normally the material used for casting the cylinder heads are made through casting process. The material used is called ductile grey cast iron and alloyed with some other critical materials like manganese, silica, nickel, chromium, magnesium, etc. This is about the bare cylinder head. Let us have a look of this figure here, these two figures. This is the bare cylinder head, what we discussed. These are the valves, okay, and these are the valve springs. This is the valve guide, all these things and all. This is actually this is a cross section of the cylinder head at valves area. This used to be considered as 4 valve per cylinder head, because these two valves, you can see these two are exhaust valves. These two valves are simultaneously operated by a single rocker arm with camshaft. This is the overhead camshaft, and some other engines are with the side camshaft, which are again operated through a short mechanism. This is the overhead camshaft. This is overhead camshaft. These are the cam roller. This is a rocker shaft. This is a rocker arm. Okay. These are called the tappets. This is called crosshead, which operates the both valves simultaneously. And if you cut the cylinder head in little bit away, you can see the injector placement here. This is what we discussed about the injector sleeve in the previous slide. This is the injector. This is again fuel piping, etc., etc. Actually, this is how it looks like this. After the cylinder head, now let us discuss about the valves. This is the complete valve assembly. This is the valve. This is called a spring collar, where the bottom portion of the spring sits here, and it is on the top of the head. This is the valve guide, which is having hollow tube, The stem of the valve will be inside this valve guide. This is the outer spring, this is the inner spring. Some engines are provided with 2 springs and some engines are provided with a single spring. This is called spring retainer or spring collar. And this is called the spring split collar. This is again called stem cap. Over about this there will be rocker arm, then below there will be push rod, then there will be cam follower, cam lobe, etc. What we have seen in the previous slide. These are all the parts, various parts fitted inside the cylinder head. And this is what we have seen in the previous slide, the valve operating mechanism, or this is called valve train or valve operating mechanism. So when the camshaft rotates like this, in this position, because of the lesser radius in the cam lobe, the valve is in closed position. When lobe comes here, this push rod is lifted. When this push rod is lifted, this rocker arm, this end is lifted and this end is pushed down. When this end is pushed down, this valve is pushed down, creating a passage here. Please understand. Creating a passage, if it is inlet valve, the fresh air is entered from outside to inside. If it is exhaust valve, burnt gases are scavenged from inside to outside. This is how the valve operates. The spring is provided to hold the valve against the head face, closing always. Whenever it is necessary, whenever the lobe reaches here, for that movement, in relation to the piston movement inside the cylinder, this valve is opened and closed. Example, if it is a inlet valve, when the piston travels from TDC to BDC during the suction stroke, this loop will be in this position and push rod is lifted, rocker arm is lifted here and rocker arm is pushed here down and pushing the valve open. As soon as the suction stroke is over, the lobe is rotated further like this, bringing the valve back to its seating position with the help of the spring here. Now let us look about the individual part. This is the valve. This is only about the valve. This portion, top portion of this complete top portion is called the valve stem. This bottom portion is called the valve head. Again in the valve stem, there is a groove provided here to secure this lock firmly in the head. This collets comes and sits here, locking this valve. Then this is called tip. Tip is the very hardest material in the valve because it's always subjected for opening and closing to this rocker arm. And this joining place between the stem and the head is called fillet. Recommended amount of fillet radius is maintained as per the manufacturer's guideline. The bottommost portion, this front portion of the head, is called as combustion phase because this is the area exposed to the high temperatures inside the cylinder. This is called margin, and this taper area is called the seat face. This is the most critical one in the valve mechanism. This portion and valve seat portion should always mate each other. Once this is worn out beyond certain limit, either you have to reface the valves or you have to replace the valve. This is about the valve. Now I told about the valve parts. I would like to say, as told, all the modern engines do have 4 valves per cylinder, 2 inlet valves and 2 exhaust valves. The size of the inlet valve is slightly larger than the size of the exhaust valve. Why? The valves looks like this, finished valves, because the fresh air whatever is charging inside the engine will be at atmospheric pressure, means around 14.5 psi, or if it is a turbocharged engine, it will be slightly more because the air is pumped through turbochargers forcibly, whereas the pressure remains to 40 to 50 times of the inlet air pressure. To allow more quantity of the fresh air, the inlet valves are designed little bit larger than the exhaust valves. And when it comes to the material, number one, these are always moving inside the guide, inside this valve guide, and there is always hammering action on this valve tip. So, and this valve face or valve head is exposed to the tremendous temperature, both inlet valve and exhaust valve, in the combustion chamber. They should be again withstanding for all thermal loads and mechanical loads. They should possess the minimum thermal expansion property, and also they should be wear resistant. Particularly in the exhaust valve, the exhaust gases passes through the exhaust valve with a temperature of around 400 to 450 degrees Celsius. So the stem and the seat of the valve should be able to withstand for that temperature. So the material used in the exhaust valve is slightly different from the material used in the inlet valve. The valves are made with the silicon chromium steel or austenitic chromium nickel steels, and the valve heads are forged. Valve heads are formed through forging process. Now let us look into the valve seat. This is the valve seat. This is with rectangular cross section, having tapered area to like this to accommodate the valve head seating area. This is valve seat, and this should accommodate this valve head seating here actually. This is how valve seats are inserted in these respective places. There's 2 grooves for exhaust valves and 2 grooves for the inlet valves. This is how the seats are inserted here, and this is the portion you can see here is the cross section of the valve seat. You can see the slight tapered position. This is how it is fitted here. And as this valve head and the cylinder head face is always subjected and exposed for the high temperature, the valve seats also are exposed to the high temperatures because these are also in the combustion chamber. The valve seats should be able to withstand for all that high temperature and other stresses, mechanical and thermal stresses, because the way this valve is operating, up and down movement, and same way the force will be there always, hitting force will be there during the valve opening and closing. They should be able to withstand all such hammering actions along with the thermal loads. To withstand all these thermal loads, the seats are made with cast iron alloyed with some critical metals like silicon, phosphorus, molybdenum, chromium, etc. Then next let us move to the spring. This is the valve spring and this is the spring retainer. This is valve spring and this is a spring retainer. Springs are placed like this. This is the spring retainer. You can see this actually. This hole is provided for the valve stem movement, and the bottom one is this one, spring collar. This is actually so where the spring is secured without moving this side or that side. The main purpose of the spring is to secure this valve normally in closed position with the help of this spring tension. But as and when required, the valve is opened by pressing the spring, and the sooner the load is released on the valve, Due to its spring reaction, valve comes to the normal closing position. This is the job of the valve spring. This is the valve retainer. If you see the face, it looks like this. But inside this, you can see these split pieces again. Two split pieces. What are the split pieces? These are the split pieces. These are called valve collets or valve locks. Okay. Stem valve stem comes here, and these locks will be placing in these grooves. The outside diameter conical surface is secured within this retainer, whereas this exposed surface is inside this groove, so that it locks the valve in its position. These are called the rotocoils. What is the job of the rotocoil? Some older version engines will be having these retainers. Majority of the latest engines having these rotocoils. It will be rotating very slightly like this, like this, like this, like this, when the valve is moving up and down. The mechanism inside, there is some spring, all these things and all. Why these rotocoils are provided? When the valve is moving up and down with high velocity, because of the continuous hammering action and the valve seat, the wear is very rapid, and also there is a possibility of embedding some foreign particles between the valve seat, between these valve seats, this valve head and valve seat, which is causing uneven wear here. Okay. So to avoid that and to give the uniform wear, in addition to the up and down movement, valve has to rotate simultaneously, give some circular movement like this. So like this. To give that movement, these rotocoils are provided. This is about the cylinder head assembly, that is bare cylinder head and other parts fitted in this. I am here giving the 4 pages of notes, capturing some important points. And if you have any questions or queries, please email to me. Friends, hope the contents of this video is useful to you. If you have any questions or queries or suggestions, please email to me or WhatsApp to me. Thank you for watching this video.